Good evening, then we will start. This is the session number 3. Last 2 sessions, we were talking about how to draw the model, basics in developing the graph or the map, PLS. Then we talk about basically the measurement model first, or you know that as the outer model or the external model, different terms we use. We talk about that one and also how to assess the measurement model. I think that's a basic thing first you have to do in the PLS or any SCM software. Step 1 is to assess the measurement model or the outer model. Then last time also we discussed about what are the criteria you have to look at. We talk about validity, reliability, and also invalidity, AVE, convergence, and also discriminant validity. Further, we talk about the model quality indicators also, SRMR. Then I think norm fit index is also there. I don't know whether I mentioned that when you run the analysis, there is another thing called norm fit index in the quality criteria. That should be above 0.9. Then we like it's a good model, norm fit index. 0.9 and above are good. But SRMR is error. That should be less than 0.1. But norm fit index is something positive. It should be above 0.9. In some models, you can't find norm fit index, that is not calculated. But in some certain models, you can see that is calculated. If it is calculated, you can report that as well norm fit index, that should be above 0.9. But SRMR should be less than 0.1, both for saturated model as well as the estimated model, which I mentioned last time about the model quality. In addition to that, in PLS, not like AMOS, you can see QV square, that we call predictive relevance. That also should be above 0, maybe 0.1, 0.2, 0.3, like you can see, and you can report that also predictive relevance. It should not be 0 or minus, then your model is not good. Further, FP square, that talks about the effect size, that also you can report. In addition, R square also you can report under quality. That's a norm in PLS, not like in AMOS. Then these are the basic things we talk about last time. Then for the last time I talk about how to create the moderate effect also. Moderate effects you can easily create. We call the multiplicative effect. Last time we discussed and how to assess the moderate effect and how to interpret that also I mentioned. It can be positive moderation or negative moderation. Then today, session number 3, last session, we are talking about 4 basic but very important things. One thing is about mediation. Maybe some of you might have already done this mediate analysis. Sometimes in SPSS, you know how to do that. The same process you can practice. That is one approach. We call hierarchical linear regression approach. That is also possible here. According to Baron and Kenny's 3 guidelines. If you refer to Baron and Kenny 1986 in Google Scholar, their article, they talk about how to assess the mediation effect. Maybe either PLS, AMOS, or normal regression using SPSS. There are 3 steps. That is also possible. Today I will show you how to do that. The other approach is direct and the indirect effect. You can see in the reports. These are the 2 basic approaches. You can see the mediation, whether there's a mediation, full mediation, or a partial mediation. We will discuss that one. In addition, we will discuss another thing about this multi-group analysis. That is something unique and novel in PLS. You can compare your path models, subpath models, broken down into group levels. You can compare the groups and the path significance between groups or among groups, multiple groups. That's also very interesting analysis. We call multi-group analysis. We will do that second. Third, I will do something about this tetrad analysis, confirmatory tetrad analysis. I mentioned in PLS, another unique thing is about how to assess the measurement model indicators, whether they are formative or reflective. But if you look at AMOS like software, SCM, you will see only reflective models, right? That means construct, reflect the indicators. That means arrows are headed towards the, what do you call these squares or the indicators from the circle construct. That's a traditional way AMOS has. Still, AMOS has this reflective measurement model. But in PLS, the advanced function is you have both. In your model, you can have, like now here you can see in this shared screen, you can see this is reflective model. But sometimes with the reflective, certain things can be formative. I have that option here. Last time also I mentioned. Now look at here. Can you see the screen? Shared?
Yes, we can see.
Thank you. Now here, let's say something price. Let's say price. Sometimes I might have measured, let's say from literature, I have known that these indicators are formative. Then you can see this. Then therefore you have this option. Some can be formative, some can be reflective. In PLS, you have both options. In the same model, you can have both. Some are formative construct, some are reflective construct. Or all can be sometimes formative. That is also possible. But in AMOS, you don't have that option. You have to be all reflective. But when you look at exploratory model building, novel instrument, questionnaire development, some can be formative in new concept development. That's why in marketing, this is very important. Marketing and also in other social sciences also, when you develop new instruments, some can be formative. That can be backed by literature. But if there is no literature, when you develop a new tool, that's why I mentioned my third technique today. What do you call this? Confirmatory tetrad analysis, where you can decide whether your measurement model, let's say particular construct, whether it's a formative or reflective, right? That guide you. Therefore, if you develop a totally new model, sometimes you don't know whether it's a formative or reflective. You don't have literature in the new context and new model, a new variable, new indicators. Therefore, PLS help you through this, what do you call confirmatory tetrad analysis, whether reflective or formative, right? That is also justifiable. But you can identify and further you can back with some literature and interviews when it's a new model. Therefore, that option is there. That's the third one we are going to discuss today. And the last one or the fourth one, I will simply show you how to develop sort of a, what do you call, indigenous variable. Now here we call indigenous variable means the particular dependent variable, another term we use, right? You are trying to predict something. Now in this model, what's the indigenous variable? Now here I'm having four main constructs. One is reputation in short, let's say reputation. The other one price, the other one satisfaction, and also fourth one loyalty. What's the last variable which I want to predict?
Loyalty.
Yes, loyalty. That's the indigenous variable we call, right? Indigenous variable. Now here you can see, this is the, if you look at the reputation is a second order construct. Why I am saying so, you can see quality, leadership, corporate social responsibility, governance. Those are forming, or those are helping us to develop the larger construct, reputation. Now you can see this is a reflective one, right? Now in advanced PLS, sometimes you can see reflective, formative. Likewise, there are so many advances. But our simple model is here reflective one in this one. Why? Reputation measured by quality, leadership, corporate social responsibility, and governance, which are reflective, right? You can see arrows are headed towards from the larger construct to the sub dimensions, right? Therefore, that is reflective. And further, quality and the other dimensions, leadership, corporate social responsibility, governance, they are also measured as reflective. You can see quality measured from two indicators. That is also reflective. Therefore, this is a reflective second order construct. Sometimes there can be reflective, formative, reflective. Likewise, there can be that option in PLS. But for the moment, we will discuss this one. Sometimes in your research, in the future, you might meet in under complex situation, formative, reflective, likewise, you can find. Now, my last point, I am talking about how to measure a model where the indigenous variable, here loyalty is like this. I assume not loyalty, I will show you. Now these arrows are here, no issue. This is measurable as a second order one. But there is another technique we call two-step approach. I will show you that towards the end. Now I am not going to change anything in this model. That one I will discuss, right? That is another unique thing in PLS. We call how to measure indigenous variable, which is we call formative construct, right? Which is a formative construct with several dimensions, second order formative construct, indigenous variable. That's my fourth point. When I discuss that one, you can understand. I will develop the model accordingly by that time. Okay, then my first one is the mediation. It's very simple. Last time we talked about moderation. Now here I have a mediator. Now I have given you data set, and also I have given you a particular example relevant to data set, and also several hypotheses. Last time also we discussed, but here there's a mediator hypothesis. That one I want to test. This is the one. Customer satisfaction significantly mediate the relationship between brand reputation and customer loyalty. That is the hypothesis I have in my mind model, conceptual model. But I have other variables also. But if you want, you can remove other variables in your thesis and you can separately show this. That is one option. In the thesis, if you want to have more detailed discussion, at a time only relevant variables you can keep. Others you can delete and run the model. That is also there. But here I will run in the full model. That is also acceptable in a like research paper, journal paper, like you can have this full model also. Now you can see here, satisfaction mediate. See the hypothesis, how it is written. Yes, customer satisfaction significantly mediate. Now you can say reputation is the independent variable in this case. Loyalty is the dependent variable. Satisfaction is the mediator variable. That means you can see there's a direct effect from reputation to loyalty arrow. In addition, there's an indirect effect. We call indirect effect is this one. Reputation meet loyalty via a different path, indirect path. That means reputation goes to satisfaction. Through satisfaction, via satisfaction, reputation goes to loyalty. That we call indirect path. Remember, right? You should know this meaning as well. What is a direct path? What's the indirect path? Direct path is directly reputation to loyalty. Independent, dependent. They directly meet face to face. But in addition, mediation we talk about, there's an indirect. That's the case. That means reputation goes to satisfaction. Satisfaction goes to loyalty. That means each other knows, right? Each other's role. Therefore, when you run this model, you have to identify what's the direct path, what's the indirect path. That is very important in analyzing the report and when you report also in your thesis. Now, I will normally run the model. Last time also I mentioned you are not going to run here normal regular PLS algorithm and the bootstrapping. I gave the reason last time. I will do here consistent PLS algorithm to develop the path coefficients and the factor loadings. After that, to get the t values and the p values for the significance, I will do the consistent PLS bootstrapping. Since the model is fully reflective, that's the case. In the reflective model, we use consistent one, which were later developed. But traditionally for the formative one, we used still formative ones. We use normal regular algorithm and the bootstrapping. Remember. Now here I will go for consistent PLS algorithm. Now I assume I have developed the model and improved the model, right? Last 2 weeks, we talk about developing the measurement model, removing some of the indicators which had poor factor loadings, and also maybe low correlation with reference to Cronbach alpha and the composite reliability. We removed some of the items. Therefore, now I assume I have improved the model. My measurement model is now acceptable. Quality criteria also acceptable, I assume. Therefore, I select here path now. But when you do the first time measurement model development, you have to select here factor, remember, right? Factor. Now I assume I have purified the model. Therefore, in your final, what do you call, inner model, structural model to test your hypothesis as a main part of your research, path you have to select here. Now you get the reports and also you can go to the model as well. But before I interpret this one again, I go to this calculate. I run bootstrapping as well. We also, that is path focus we have. But remember, when you run your final one, this should be norm is 5,000. But for the moment, I will keep 500. You need at least 5,000 subsamples for the bootstrapping and complete bootstrapping to get all the outputs. But it takes time when you increase this one. Right now you get both. You can see this is what you need. If you want, you can change here. You can go to the left side corner and you can see. If you want in the inner model, you can have path and p values or path and t values. You can see, right, when you change that one on the arrows on the graph, these values also change. Now I can see path values within bracket t values. But the norm is we look at path values, path coefficient, and within bracket p values. Right? P value should be less than 0.05. If it is a t value, it should be above 1.96 other side of the same coin, p value and the t value. If you want, you can get the R square or any other values, reliability values, right? You have that option also here. You can leisurely try these things. But for the moment, I need this one. But you can see outside factor loadings also. But I haven't purified this model. But last time I talked about how to purify the model. Still, this model has some poor loadings, like finance 2 indicator forming the finance subdimension dimension is 0.5, but the norm is above 0.7. But some people keep 0.6 also, depending on your argument. But when you have such things, when you go to your PLS algorithm, sometimes your quality criteria and the what do you call construct reliability might not be good. That's why this red color is there, right? Sometimes these things are not good. Therefore, you have to remove some indicators and improve the model. Last 2 weeks we talk about, including discriminant validity also. Quality criteria, you can see F square, R square, and also model fit. I mentioned saturated and the estimated model SR, MR, and also norm fit index. It's not calculated here because of some limitations of the data. But in some models, you can find these things. I'm not going to repeat this. Last time we talked about. Now see here in this report, you can see indirect effect, total effect as well in the reports. But first I will go to the graph. I'm interested only now in the inner model, structural model. You also am interested only in about the mediation, though there are other moderating and other variables also are there. But for the moment, I'm interested in only these 3 paths. That means reputation leading to loyalty, reputation leading to satisfaction, satisfaction leading to loyalty, right? On this, within the circle, you can see the R square value. Now I am interested in knowing my hypothesis about the mediation, whether satisfaction mediate the relationship between reputation and loyalty. Now you can see all three paths are, to a certain extent, you can see significant. No, I assume this is also at point 1. This is anyway significant. But if you look at 0.05, this is just above 0.05. Therefore, this is marginally significant. You can see reputation leads to satisfaction. We will assume for the moment this is also marginally significant, but ideally it should be less than 0.05. If we are looking at 95% confidence interval or 0.05 confidence level. But for the moment, I will assume marginal, this is also significant. Therefore, I see this path, reputation to satisfaction path is significant. At the same time, satisfaction to loyalty path also significant. That is also less than 0.05. Therefore, you can see these are the indirect path, right? Indirect path. Now, indirect paths are significant. That means indirect paths are significant. At the same time, direct path you can see. What's a direct path? Directly reputation leading to loyalty. That is also significant. That is also significant. Then what is the implication? Now we will assume this is also around 0.05, therefore significant. Now all three paths are significant. Direct path is significant. Indirect path also significant. Now what's the conclusion? Simply you can report these three paths and talk about Baron and Kenny's guidelines also when you report that one. What's the conclusion? Whether there is a mediation of satisfaction or not. Now, how can you interpret whether satisfaction mediate the relationship between reputation and loyalty or not? That's the question number 1. Second one, if mediating, what's the nature of the mediation? What's the nature of the mediation? Whether it's a perfect mediation or the full mediation or partial mediation. These are the two questions you have to answer. This one is answering in the chat box. Yes. There is a partial mediation between reputation and loyalty. Yes, correct. It's a partial mediation. Why it's a partial mediation? All three paths are significant. That means there is no pull mediation. If there's a pull mediation, what's happening is that this direct effect is not significant. If this is very close to 0 and p-value is above 0.05, you can say, hypothesize a scenario, think about scenario, this path is not significant. At the same time, direct paths are significant. That means there is a perfect or pull mediation. But in this case, all three parts are significant. That means there's a partial mediation, right? That means satisfaction does not fully mediate. That mediate to a certain extent. There can be some other mediators also other than satisfaction, which is further researchable. That is how you interpret and write. Now, if we assume this one is very close to 0 and p-value is a very big value above 0.05, that means this is not significant. That means direct path is insignificant. That means there is no direct identification link between reputation and loyalty, but still indirect paths are significant. We call that's a perfect mediation. When you are having these three paths significant, direct and indirect, we call this a partial mediation. That's a very basic steps also according to Baron and Kenny. That is one method you can see. That means according to Baron and Kenny's articles, if you read their steps, first independent dependent should be significant without mediate. We call that's a total effect. Next, I will explain what's a total effect, right? Then independent mediator should be linked. Then mediate and independent also, mediate and the dependent also should be linked. These are the three conditions you have to fulfill. After that, you have to run the model with all these and see the path. That's the Baron and Kenny's steps, what we discuss here, right, in this model. If you read this article, you can understand those step by step. Any clarification up to this point? Mediator we call another term intervening variable, right? Moderator we call interaction variable. That's why we had multiplicative effect here. If I show you, you can remember last time we talked about. You had all multiplication effect. Independent and the moderator multiplied and create the multiplicative effect. That's why we say multiplicative or the interaction effect. But here we are having mediating or the intervening effect, right? Intervening effect. Hope you are okay up to this point. Then I will go to reports. Look at the direct and indirect effect. That's the other approach you can report. In addition, if you go to the internet, you can see Sobel test also, right? Online, you can check the significance of the mediation using Sobel test calculator on the Google, where you have to report the, what do you call this, standard errors of the path coefficients, and you can measure the significance of the mediation, but that is not required. These steps are sufficient. Right? Now, if I go to my results of the algorithm, you can see here under final results heading, path coefficients are there. You can see that, right? Reputation to corporate social responsibility. These are the dimensions and the construct related relationships. But you can see reputation and loyalty. 0.793. That is shown in the graph also, right? 0.793. Same thing shown in the report also. Therefore, be familiar with the report and the graph also, right? Certain things in the path you can see in the report also. You can see reputation and loyalty. This is a direct impact. Significant direct impact, 0.793. Further, you can see reputation and satisfaction link, 0.221. That is also shown in the graph, 221. Those are the ones in the model. But when you go to final results here, after the path coefficient, you can see there are two things: indirect effects, total effects. First, I will go to indirect effects. Now, there are different indirect effects for different variables. By my concern is this: indirect effect of reputation on loyalty. Therefore, you have to find this one. Yes, indirect effect. You look at reputation, meet, loyalty, that one. What's the indirect effect? 0.068. Very poor indirect effect is there. Very poor, right? Very poor indirect effect there. That means it is not a perfect mediation at all. And also mediation indirect effect also very poor. You see there. That is even less than 0.1. It is 0.07 when you round up. It's a reputation independent variable. This is a loyalty. That's a dependent variable. Between them, the indirect effect is 0.068. If this is 0, no mediation, right? Remember, normally mediation means there is an indirect effect, no intervening function in between loyalty and reputation. In this case, that is 0.068. Very weak mediation is there of satisfaction, right? Therefore, you have to look for another way to report, looking at indirect effect of independent on the dependent variable. That is here very poor. If it is 0, no mediation at all. No mediation at all. That also you can explain in your presentation or in your reports. Then there's another thing, total effects. You can see here. Reputation and loyalty total effect is 0.861. Total effect. That is not shown on the graph. Remember this, 0.861. That is not shown in the graph. But I will show you in the graph now using a different technique. Are you okay up to this point? Any feedback? Are you okay up to this point?
Yes, Dinesh, sir, we are okay.
Okay.
You can go ahead.
Thank you. Hope you can see my screen, and there's something like this. Total effect. Remember this one. This very common sense. Total effect equal simply logically direct effect plus indirect effect. Now here total effect you see on the reports, no? That is reputation's total effect on loyalty 0.861. Now you can simply check this. You know the direct effect. Direct effect is there in the reports. Reputation direct effect on loyalty 0.068. 0.068. 0.068. Sorry, direct effect, no? Direct or indirect? Indirect, no? Tell me if I'm wrong. Indirect effect, no? Yes. Now we don't know the direct effect, but direct effect you can see here. What's a direct effect? That is on the graph. This is a direct effect. This is a direct effect. This is the indirect path. This is a direct effect. What is that? 0.793. That is in the report also, right? And the path coefficients. Reputation, loyalty. Path means direct, usually, on the graph. 793. 793. 0.793. You can see. Approximately, you can see this. When you add these two, it should be equal to this one. Right? That's a very basic fundamental thing. Total effect equal direct plus indirect. Total effect separately given in the reports. Indirect also given separately. The difference is direct. Direct is given on the path coefficient in the pull model. But if the indirect effect is 0, you can say no mediation. That is another way to explain, interpret your report. But according to Baron and Kenny's approach, you can see these path significance also, right? You can see. Then this is the indirect path. I can explain how to get this one mathematically also very simply. Now indirect effect is 0.068, no? How it comes? It comes simply this way. These are the two indirect paths, no? 0.221 multiplied by 0.091. 0.221, 0.221 multiplied by 0.309. When you multiply the indirect path coefficients, you get the indirect effect, right? Approximately. Are you clear up to this point? This is additional elaboration. You should know what is the mediate, what is the indirect, direct, and the total. That's why. If not simply for your thesis, you can explain by looking at these things, Baron and Kenny's steps, or the total and indirect effect. But you should know the rationale behind that. That's what I explained. I think Professor Jayanta, is it clear? I think Mr. Lasantha, are you there? Is it clear how to calculate this one and explanation?
Yes, yes.
Okay, that's about the mediation. Mr. Shenal is there, no?
Just one question.
Yes.
Now, when you say now for full mediation, this direct path must be insignificant, is it?
Exactly. There is no direct.
Okay.
Fully, they understand each other only through a third part.
Okay. So if there is some amount, whatever the amount is, as long as it is significant, then we say there is partial mediation.
Yes, yes, yes. Significance level is the one you have to judge. But you can say very poor partial mediation, you can say in this case. It's very poor, no? You can see it's even less than 0.1, that value. This is a very indirect effect is very, very poor, but significant, but small effect. That means there can be some other mediators which are outside the model, Mr. Lasantha.
Understand. So if the indirect effect, for example, is the figure is much larger than the direct effect,
If
then what would
indirect
it
effect is
much larger than the direct effect?
yes, simply you can do like this. You know the total effect, no?
Yes.
You can do simple calculation percentage. Now indirect effect is 0.068. Divide that by total effect.
Right.
861. Ultimately multiply all by 100. Then you can see the percentage.
Okay.
That's very simple mathematics. Here it can be less than, I think, 10%. No, even less than 10%. You can, I can't calculate now here. It can be less than. Then you can say 10 mediation effect is 10%, 50%, 70%.
Okay.
That's how you can see. Clear, no?
Now I understand. Yeah, okay, clear.
Whereby you can argue there can be some other mediators also. If there is no perfect mediation, definitely there can be further research to identify other multiple mediators. That also you can suggest. Mr. Shenal, are you there?
Yes, sir. Yes, I'm here.
Are you okay?
Yeah, sir. I'm okay, but I think we are almost certain with the direct and indirect effects. Just want to know, like, since we have price also, is it now, since I know this is not up to now, but price is moderating our satisfaction. So if we consider this model, sir, is it what we call mediated moderated model?
No, that's a different thing.
Okay, sir. Okay.
Mediated moderated mediation, it's a separate thing. But this is a outside mediator, not to the loyalty. It is to a different variable, no satisfaction.
Okay. Yes, sir. I'm clear with the mediation, sir. Thank you so much.
Thank you. Then we can go to the next step. That's about this mediator and how to identify the percentage of the mediation. Then we can go to second part. That is about multi-group analysis. And further, when I go to this one, in the reports, you can see so many things. I think last time I could mention collinearity also there, right? Now in this model, I extracted this from a larger data set, but this extracted data set is not a good data set I got. Therefore, there are some issues in this extracted data set. You can see here, VIF values are very high. We call this a multi-collinearity diagnostic. Variance inflation factor, usually we say less than 5 should be acceptable. But you can see a lot of variables here, like indicators like finance 1, finance 2, those are having huge level of VIF. Therefore, remember, when you are trying to run a model, sometimes model might not, bootstrapping might not work when you are having VIF values, very large values. sometimes you get an error. Not now, but sometimes in some research, you get some errors when you run the bootstrapping or the algorithm. The particular algorithm does not run. It stops somewhere, giving an error. Therefore, you have to be very much careful when you get these things. You have to remove these things. But for the moment, I have removed. But you have to remove these. If you're having these things, some advanced analysis you cannot do. Sometimes we call singularity effect. Singularity matrix error is there. There are different terms coming, errors. Now, in this case, I found that I cannot run the multi-group analysis with this data set because of these high values of these indicators indicating high, what do you call, multi-collinearity. Therefore, I had to remove these. Sometimes even some construct. Therefore, you have to be very much careful in your pilot test when you develop the tool before you do a mass data collection to improve your model, having a pilot sample, right? Small sample, maybe to do some, maybe VIF and some other issues. Therefore, I cannot run this multi-group analysis using this data set. Therefore, for all this model, therefore, I created a different model from this same data set. You can see that one here as different path diagram. This is the one I extracted from the same data set, right? For you to explain. I have loyalty, satisfaction, and I got another one, quality. But that is not the original model. From that, I extracted and created new model. Since the original data set is having some issues with the multi-collinearity. Therefore, I had to reduce those things and run the model. But for the moment, I selected these three variables. I created a new model. I have independent variable quality, then satisfaction, that's a single indicator, then loyalty, three indicators are there. Now, this is the model. Now, my task is to do a multi-group analysis. The concept is, now here I will explain the data set. If you go to data set, you can see here indicators. And last, I have one indicator, which is not a scale one. This is a nominal one, categorical variable. I have identified two groups of companies. Now I have measured their CSR, loyalty, and so many constructs. At the same time, I have identified the nature of the company, whether it's a profit-oriented company or not profit-oriented company. That's my type variable. That's a nominal categorical variable I have. You can see here. Therefore, if we're having such variables, we call sometimes, you can see in this one also I have asked about this, we call categorical moderation, categorical moderating effect of business type. For such moderation, it is not nice to create a moderate variable in the model like this. That is also possible. But when you are having a sort of continuous type of variable, you can create a moderate effect here. But you can, for categorical also, you can do it. But we call categorical moderation, you can present more comprehensively using this multi-group analysis when you're having nominal variables. But both approaches are possible, right? That's why I want to know the categorical moderating effect of business type, not profit versus for profit in the model. There's a significant, yes, Mr. Lasantha, yes.
So what you're saying is the dependent or the endogenous variable can be treated as a categorical variable.
No, not the dependent, not the dependent. This is the particular additional variable in the model, which can be an independent variable line. Not
Okay, so
never dependent.
So the dependent variable cannot be grouped.
cannot be categorical.
Okay.
In
Why is
PLS,
that?
remember, dependent variable should be always continuous or any discrete, but not categorical nominal variable, dependent. But other variables, mediator, moderator, independent, control, other variables, except the endogenous or the dependent, can be even categorical or any other type. But remember, in PLS, always dependent variable or the another term, endogenous variable, what you are going to predict, should not be categorical, should not be nominal. That's a must. Now here I am going to talk about, you will understand when I do that, whether company type affect the relationships, strength or something. I will explain. Now in my data set, I have collected type of the company as well. That's why I can show you here. The raw file also you can see. Last one, in my questionnaire, I have a nominal categorical variable asking the type of the company. Yes, Mr. Lasante, yes.
Sorry. So does controlling effect also has an impact like this?
Yes. Yes. It can be a control variable sometimes, which affect dependent variable. Control variable also theoretically independent variable.
Okay. Right. Okay. Right. Thank you.
Yes, it can be control variable sometimes. Yes. Some people ask now whether you control your model for the company size or the gender as controlling variables or moderating variables. In that case, you can say, yes, I had a multi-group analysis. Here, type of the company. If you look at here, you can see my minimum value is 1. Maximum value is 2. That means for the company not for profit, I have given 1 to identify them. For the companies, profit-oriented companies to identify, when I enter data, I have given 2. But this is not really a value. Just to identify, categorize 1 and 2, 0, 1 line, nominal value. But this is not having any mathematical law, any measurable value, just to identify. It's just a label, 1 and 2. Therefore, you can see type of the company. If it is not for profit, I have given 1. If it is a profit-oriented company, I have given 2, just to identify. That's a nominal variable as a control variable or moderating variable, which is a categorical moderation. We say that. And also remember, when you import the data set, always you can see your raw data file, indicator correlations, and also indicators. And when you see indicators, you can see the mean value. By default, it's generated, right? Before you run the model, median, minimum, maximum. Then you can see whether there are any errors in your data set, minimum, maximum values. Beyond that, are there any values? And remember, standard deviation is also there. And remember, when the standard deviation is 0 for any of the indicator variable, your model might not be a good model. That means there is an error. Sometimes you cannot run the model when there are standard deviation is 0 values. That means when the standard deviation reflecting variance, when there is 0 variance, PLS cannot run the model, right? Variance is the base on which all the calculations are done. That's why we say it's a variance matrix based method. Therefore, remember, sometimes you might get errors one day when you run the model. In that case, remember to see your standard deviation. If it is a 0 for some variable, then there is an issue. That variable cannot be taken into model. Therefore, you cannot run the algorithm in most of the cases. That is my experience. Therefore, remember, this is something additional. I just want to highlight. It's a raw data set which I imported. Last time also I mentioned this. Right. Now, I have one categorical variable type. Then first, I will go to usual. Now here you can see when you go to this data set. Now this is the graph I developed for this multi-group one. I have only 3 variables for the simplicity. When I go to data set, you can see here, there are 3 things relevant to groups. Can you see icons? Add data groups, generate data groups, and also clear data groups. You can see three things: add, generate, clear data groups. For the moment, I will go to generate data groups. Since I have in my questionnaire data set, I have identified, entered some groups. Therefore, simply I have to no need to add. I have to simply generate. I click on that, generate data groups. See here, you can give a particular name as a prefix. I might say company type. Company type. At least one column you have to select. Here you can see my variables, indicators. At the end, you can see type, company type. Two unique values, no? 1 and 2. 1 for profit, not for profit, 2 for profit. I select that one. Here you can decide minimum cases per group. Sometimes you can improve this, right? 100. That means to group any variable, at least that should have 10 cases. That means here 1 and 2, no? Then I, by default, it's 10. That means at least, let's say, if it is 1, there should be at least 10 1. That means not-for-profit organization. Then only it is taken into a group. When you're having too many low cases, this analysis cannot be possible, right? Observations are not sufficient. If you want, you can improve this if you're having a large sample. For the moment, I will keep that. At least there should be 10 minimum cases for a group to identify the values and form a group. You can change that. 1 and 2. Now that's the thing. I'm going to generate groups, already available groups. Okay. Then you can see, right? It's coming here. My sample size is 95. You can remember original sample size cases. Company type 1, 1.0, that is the number given. 2.0 for profit-oriented organization. Altogether, this is in this group, there are 52 companies, 43, altogether 95. You can see. If you want, you can go to edit here and give some labels as you want. Company type, sometimes you can give here no profit. That is selected, right? Type equal to 1. That is, I have indicated earlier. That's why it's there, right? Number 1 equal to no profit organizations. Okay. This one also I can edit. Sorry, not that one. This one. 2. Edit. Profit. That is 2. That is already decided. Now you can see, right? Whatever the label you can give. Now I have created the groups. Now I have created 2 groups. And remember, if you want, you can further add new data groups also. Remember. Something like this, add data groups. You can create new data groups. I might say, for example, price high. From my existing variable, I can define new data groups. Price high. I select one, not a categorical variable. This continuous variable I can select. For example, price 1. Now price is having, you can see the values, right? I might say like here, you can see. High price, higher than, it's from 1 to 5, we will assume we have given in the questionnaire, like at scale or something. Higher than 3. Price high. So many groups you can create as per your requirement. Now you can see, right? That is also added. If you want, you can edit that. I add another group. Price low. Same variable I select. From that, I create another group. Price low, no? Let's say lower than 3 or 4, right? Lower than 4. This is just for example. You can see I have added some groups and also generated from existing groups also. So many groups you can create, right? This is the first task. Yes, someone had raised the hand. Please ask. Someone raised the hand. Any clarification up to this point? Hello? Okay, you are okay up to this point. Mr. Lasanta, are you okay up to this point?
Yes, I'm okay.
Okay. So many groups you can create. You can generate from existing groups, or you can add data group from existing one, creating from different logics, right? You can leisurely try this one. Now I have created. That is also done. Now I go to my particular model. Initially, I went to data sheet and added groups. Now I go to my model. Now I go to calculate and simply go to consistent one. I run PLS algorithm as usual, right? Now data groups you can see here. New one is created. Now you have to select whether you need all or several. If you want one, you can select one. If you need all, select all. Now you are doing group-wise calculation also in addition to the main model, right? Start calculation. Now you get the reports as well as the graph. I will go to the graph first. Now this is the overall model. You can see here, right? Left-hand side down there, you can see here. Lower side, data group complete one. That's a full model. But now you can see different models. Do you see? If you want, you can break down 62 case of no profit companies. See now graph, when I change this, graph values are changing. Do you see? For subgroup, path coefficients are calculated. Now I select profit. You can see path values are getting changed. I select high price, different values are coming. Only for that subsample, right? Subgroup. Price low, you can see different values are coming. As you want, you can get the pictures and report, right? At different group level, what's the impact of different variables, even the moderation also. Mediation also, you can see. And there's a nice thing further, very nice part is here, highlight part. You can use the relative values. Do you see? Relative to the path coefficient size, they calculate the arrow. This is a very bold one. But the poor coefficient is very, right? You can see not bold one. This is a somewhat bold one. That's the use of relative values or of that for the normal one. Or use absolute values. That is also there, absolute values. But we like relative values. Therefore, you can see which path is there. You can try this leisurely. That is the multi-group, not the analysis. This is a multi-group diagram. Still, I haven't done multi-group analysis. Remember. Any clarification? Any clarification up to this point? Mr. Shenal, are you okay up to this point?
Yes, sir, I'm okay.
Then I am trying to do the multi-group analysis. That's the most important part. Now it's a diagram only. You can have the inner model with the path values and p values. You can run here even the bootstrapping. That is also possible. All the normal things you can do with the groups. I have selected path focus. Therefore, you don't have to separately break the data set and run several what do you call PLS. In the same model, you can have several models group wise. At a time, you can see one model as you want. If not, some people have several regressions or several PLS diagrams separately. That is not required when you're having variables to break within the same data set. That's a convenience. You get all the reports, usual reports. Now you can see path value and the significance. Complete model, no profit group, profit group. Likewise, you can see. And also relative sizes also you can see. You can see how they change. Therefore, that's a good way to visually present, right? Good visualization technique. Right. That's the group creation and the model. But for the multi-group analysis, to generate comprehensive reports, you have to go to calculate button again. Now here you can see multi-group analysis icon is there. Now we are going to do multi-group analysis after creating the groups. Multi-group analysis. I click that. Now here there are two groups. You can comparatively you can decide, right? Let's say company not for profit against profit. That is one thing. The other one high price, here low price. Likewise, you can decide the groups as your requirement. Now I decided which groups I want to compare. Start calculation. Very simple. Now there is no graph here, right? Important thing is this one, multi-group analysis report. Remember. Now this is the one you had to use in the discussion and in the reports. Here you can see three important things are there: PLS, MGA, multi-group analysis, parametric test, and also bootstrapping. These are the three things mainly you have to look at. In the PLS multi-group analysis results, you can see here, you can expand each column, right? These are the path in your model. Quality to loyalty, quality to satisfaction, satisfaction to loyalty. Separate paths you can see. You can see here for each path under different groups, the difference. See here, first one, path coefficient difference. That means path coefficient of company type, no profit, from that beta path value, you deduct the beta value in the path value in the profit oriented companies path value. That difference is minus 0.134. That is not the path value. The difference between the two path values of the two models. Are you clear? Are you clear? It's simply when you calculate the two models, two different path values are getting, right? Relevant to one for profit organization, other one for other subgroup, not for profit. That's a difference between two path values. That is minus from one, the other one is deducted. You can see here. Then you can see like this for all the things, right? Now company type and price low company group. That is also compare the difference of the path. not for profit, it should be meaningful for your research. I just, for example, I'm using, right, these things. Now they deduct from company type 1 group's path to price low company group sets path value. That is minus something. Likewise, you can see path differences they calculate. Somewhere here you can see p value for each difference. That is also another thing. Now they are looking at the difference, path difference significance, not the path value significant. For this difference, whether it is significant or not, p value is there. It should be less than 0.05 for you to say that there's a significant difference between the path values of profit-oriented and not-for-profit-oriented organization. This minus 134 is not significant. Why? That is p value is above 0.05, not significant. Likewise, you can see for all the path differences, there are separate p values. See, I think this one is somewhat significant. Quality satisfaction relationship in relation to two groups here, right? Maybe you can see here that value is about this one. Company type no profit against company type profit. That path difference is 259. That means a big difference. Maybe one can be point, let's say 7, the other one 0.5. Path values. Difference is 0.259, which is statistically significant approximately. Like it should be less than 0.05, but for the moment it's very marginal, somewhat significant, very close. This is how you interpret that one. Further, you can go to parametric also. In parametric, you can see the same thing, right? Same values you can see. Path difference, minus 134, you can see here. And also p values also there for the original sample as well as bootstrapping sample. And also bootstrapping here, you can see these are the path values. If you want to see the path values, these are the path values. Now in the PLS, MGA and parametric, you see the difference. Remember, right? In the bootstrapping, you see the each group's path value. This difference is minus 134, right? This is given for the each path value and the significance path value is there here, right? You can see here, p values also. Just be familiar with these things and p values are also there. Are you clear? I think you can understand this one. Path differences, significance you can see here in this report. Therefore, this is the multi-group analysis reporting part, very important part. If you are talking about a multi-group analysis in your data set, belong to each sub-model, subgroup. Mr. Lasante, is it clear?
Yes, clear.
Okay, that's the second one. You can create the group as you want and you can select. You can do this trial and error and you can master yourself. Now I clear groups. If you want to clear, you can click this button, right? I clear groups. You can generate or you can create new groups from existing data, giving a logic, right? That is also possible. Just try this yourself, then you can master. That's the second part I just want to talk about today, multi-group analysis. Then third one is about this. Again, I created a new model from this data set. Reputation I created as a first order construct. Removed the dimensions and put all dimensions indicators into a single construct, right? For this example only. Then price as a separate variable, satisfaction and loyalty also I combine here. That is not correct, but for you to explain this concept, I just want to this confirmatory tetrad analysis. Assume this is a model. Don't try to link that to the previous model, right? We are having 3 variables. This one is having about 10 indicators, 3 variables, 10 indicators, here 2 indicators, here 4 indicators. If you look at this, a term tetrad means foursome. Foursome. Groups of 4. Tetrad means in statistical model, right? In statistical modeling, tetrad means foursome, or the groups of 4, combinations of 4. Therefore, if you want to decide whether this model is formative or reflective. Now this is reflective, no? But we don't know whether this is actually formative. In reality, we don't know. Like this, arrows are coming to the what do you call circle construct from the indicators. We don't know. We don't know whether this is a formative or reflective. But first you develop like this, since you don't know. But there is no literature. It's a new construct. But you draw like this at the first time. But now I want to know whether this new model formative or reflective. Therefore, I use tetrad analysis. We call confirmatory tetrad analysis. That's the purpose. If I learn after this analysis, my reputation is a formative one, I have to run the model as a formative one for this one. Then like this, I have to make this formative. After tetrad analysis, if I understand this is reflective, reputation I have to keep as it is. Right? That knowledge I gain. There is no literature. It's a new model, for example, the scenario. You might experience something like that. Now this is a model, reflective model I put as it is. Then tetrad means group of 4 I mentioned, for some. That means for you to do this analysis, confirmatory tetrad analysis, you need for each construct or variable at least 4 indicators. Remember. Unless you have 4 indicators, you can't do this. Now, in this case, I can check only for reputation and satisfaction and loyalty. But for the pricing, I cannot. That's a limitation. Yeah, but if you develop a new model, for each construct, you need at least 4 or above. Keeping in mind it's a new one. For the tetrad analysis, I need groups of 4 indicators. But at least you need 4, no? If you're developing something new. Now, this is a scenario. Hope you are okay up to this point. Now I want to judge whether, confirm whether this is formative or reflective. I start reflective. I do this one. I go to PLS algorithm more consistent. Can someone tell me? Now this is a reflective one. What's the correct approach? But in the YouTube, you can see some people are doing PLS regular one without any logic. But the logic is, if you're having reflective, fully reflective one, tradition in PLS is consistent PLS algorithm and bootstrapping. If it's a formative or fully formative or reflective as a mixture, then you can still, like if you're having mixed one also, you can go to consistent. But if you're having fully formative one, you have to go to consistent one, remember, right? Fully formative, go to regular one. But if you're having fully reflective or mix of reflective and formative, go to consistent. That's the logic. But here I go to consistent. I go to consistent PLS algorithm and I run. Remember here, I select factor focus. Now my task is not first to check the path in the inner model, but in the external model, I want to look at the factor and the model, measurement model, nature, right? Whether formative or reflective. Therefore, factor focus. But sometimes there is no big difference, but that's a no. Start calculation. Then I get the normal reports. When you get the reports, go to correlations here. You can see under base data, in the reports, under base data, last item, indicator data correlations. Indicator data correlations. These are simple correlation between variables. See, you can see correlation between corporate social responsibility indicator 1 and 1, no, same indicator, but 1 and 2, 0.786. Likewise, positive and negative correlations are there. Now, this is step 1 in the tetrad analysis. Look at the indicator normal correlations, indicator level. When you run the analysis, this is the first step. We go for the second step only if the majority of the correlations are not zero. What's your view? Are majority of the correlations here different from zero or not different from zero? This is step 1. We have to look at the correlation matrix, indicator level. You go to second step only if majority of the correlations are not zero. Here, what's the decision? Are the majority different from zero correlations? Different or not different from zero? You see the matrix here. No zero at all, no? Almost all are different from zero. Is it clear?
Yes, sir.
Yes. That means correlation should not be zero. In that case, you can't run the model also, right? That means most of the cases different from zero, 99%. If it is zero, you can't run. Most of the correlation should be different from zero. That means not zero. It can be minus or plus, any values. Here it's there. Therefore, we have fulfilled the first condition. This is for a totally new variable construction, right? In that case, correlation should be there, should not be zero, majority of the indicators. Now it's fulfilled. We see almost all the correlation are different from zero. That means plus or minus values are they are different from zero. That's step 1. Then we go to second step. Second step is this. Now you go to your model. It's a model. You can see here calculate. Confirmatory tetrad analysis. It's a step 2. Now almost all the correlation are different from zero. They are having minus or plus values. Therefore, we go for the second step. In this calculate button, confirmatory tetrad analysis is there. Confirmatory tetrad analysis. I click that. You can make this 1,000, 5,000, no, right? By default is 2 tail we keep. Again, we are doing something based on the correlation matrix. If you want, you can change this to 0.1, but by default 0.05, right? Simply, you have to run the analysis. Start calculation. It's a confirmatory tetrad analysis. Output you get. Now decide whether formative or reflective. Your measurement model. Now you get reports. In these reports, you can see final results, not the base data, final results. Under that, there are 2 things, no? We had 3 variables, no? Sorry, in this model we were talking about reputation, price, satisfaction, and loyalty. But I said that in the tetrad analysis, we talk about for some groups of 4 indicators. There are only 2 variables you can do it, no? Reputation and satisfaction and loyalty. You can do. The reports you can see therefore final results are only shown for reputation and satisfaction and loyalty. I first go for reputation construct that is having more than 3 indicators. Now under reputation in this matrix, you have to go to this last 2 columns. Confidence interval lower level adjusted, confidence interval upper level adjusted, right? That one you have to see. Confidence interval lower level adjusted and the upper level adjusted. Then you have to compare for the majority of the indicators. Here, majority of the indicators are there, right? Majority of the indicators. This confidence interval low and upper include 0 or not. 0 or not. What about these things? Now we will take first one, corporate social responsibility. Now you can see how these groups are formed. See, that is taken as a combination. Corporate social responsibility 1, 2, finance 1 indicator, finance 2 indicator. Groups of 4, they select, right? In the algorithm, groups of 4. Based on that, they measure this one, this matrix. Now here, most of the one should include 0. Not different from 0, no? Why? Here lower level is what? Minus 0.550. Upper level is minus or plus. Do you see? For the first indicator, first set of indicators, lower boundary is minus 0.550. Upper boundary is what? Can you see the value? Tell the value, someone.
9.1
Plus or minus?
plus, sir.
Right. In that case, between this boundary, 0 is included or not, Mr. Shena?
Included, sir.
Okay. What about others? Majority, whether 0 is between the particular limit or outside the limit? Always you see, no? Lower boundary is minus, upper boundary is plus in the most of the cases. Most of the cases. Sometimes there can be very few, maybe both are plus or minus. That means 0 is not there. But in this, most of the cases, 0 is included within the boundary. That means lower one is minus, upper one is plus. That means this is not different from 0. 0 is included within the boundary. If so, for the majority, then it is reflective construct. Remember, that's a rule. Reflective construct. Reflective indicators are there. But in case, if the majority does not include 0 within the range, that means majority is having plus plus or minus minus. 0 is not included, majority. Then it is formative construct. That's a rule of thumb. Here, majority and almost all include 0, no? That means plus and minus within that boundary, 0 is there. Not different from 0. 0 is included within the boundary. Within the boundary. That means this is reflective. Are you clear about the logic? Again, you can listen to this one if you are not clear to my video recording. Then this is reflective. We started reflective, and also we confirm that is reflective. Since 0 is included within the range between plus and minus. If all are pluses both sides or minuses, then majority like that, then it is formative. Now here no need to change. Especially reputation, you can see it's a reflective one. You can do the same for other one also, which is having 4 indicators. What about this one? Yeah, I have loyalty 1, loyalty 2, satisfaction 1. Likewise, 4 groups are there. Any idea? This is not a good data set. What about confidence in the lower adjusted boundary and upper adjusted boundary? What's your argument? Any volunteer? I think you can see the data set. Is Mr. Lasanta there?
Yes.
Yes. What about your view? Now for the reputation, we had almost all.
Here the results are split.
Sorry?
The results are split. One
Yes.
includes a zero, the other one doesn't include a zero.
Yes. That means I think we don't have sufficient indicators. That's the case. Therefore, we can't say whether this is a formative or reflective. Again, there might be issue. That means some can be formative, some can be reflective. We don't know. That problem is there. That means somewhere zero is included in the within the boundary, but other one, second one, zero is not there. All are up and low, both are minus sign. That means there is a problem. That's a problem in developing scales. That's why you need good content validity, pace validity, and good operational definition indicators. That can be a problem there. Again, you have to go to the field. You have to go to theory. And you have to revise. That's why in a pilot study, you have to do a good work before you go to the final data collection in the survey. This is problematic. You can't see 50-50, you can see, but even we don't have enough cases also. That's why when you have a new scale, you need a lot of indicators. Yeah, it's problematic. That is some practical issue. Therefore, you have to have the face validity and talk to the expertise, go to the theory. It's a back and forth exercise when you have something like this in scale development, unless you don't have literature, anything. Therefore, that is simply about this confirmatory tetrad analysis to identify whether formative or reflective. Yes, Mr. Lasantha.
So now how does this apply when you have a hierarchical model?
Sorry?
When you have a hierarchical model, where, for example, you have...
You means higher order?
Higher order, yes.
You can run the same thing.
But there are then indicators and dimensions both. So the indicators can be reflective, whilst the first dimensions can be formative to form the construct.
Yes, you can do this only for initially for the, what do you call this, indicator level. But again, you can get what something we call latent variable scores. There's something called latent variable scores. Using that one for the higher order one, again, you can identify indicators. Or some people get the average of the indicators and create a particular indicator for the higher order one. I don't know whether you understand what I say. Like, hello?
I didn't understand that.
Yes. Now, when you take a model like this, I think you mean like this. Sorry. It's a model like this, do you mean? No?
Yes.
Yes. In that case, first you can remove this other construct and you can go for only for this particular construct. In the construct, first you can see whether these first order level ones, you can try using this, no? I don't know whether you understand. Let's say quality
that I understand.
Minimum 4. You can do that, no?
Yes.
Yes, you can do that. After that, there is another thing. When you run the calculation, there is something called, I will show you, PLS algorithm. When you run that one, you get something called factor focus. There's something called latent variable. You can see on the final results. Here there is something called latent variable. First one, latent variable scores. Now you get something for corporate social responsibility, one value. You had 2 indicators, no? But now 2 indicators narrow down into 1 value. Do you see there?
Yes.
finance, you get one value that is between 3 and -3 and +3. We call standard deviation 1, mean value 0, normal, we call standardized. Normal distribution approximation is there. Can you see this one? These values, again, you can get into a model and try tetrad analysis again for these ones. Are you clear?
Sorry, say that again, please.
Now, yes. I will show you this model again. Now, for the moment I remove this one and I run only for this model, I created this as some of the independent or the dependent variable, but I don't know whether this is a formative or reflective. For the moment, I can identify for each and every variable. This is as a reflective, and I can run the tetrad analysis, no? Only for this.
Yes.
That is clear, no?
Yeah, that is clear.
Okay. When you complete that one, you can run the calculation, no?
Yes.
For a normal model.
Yes.
When you run the normal model like that, there is something called in the report latent variable. Latent variable. In the latent variable, you get something called this matrix. First one, latent variable. We call these other latent variable scores.
Okay.
Are you clear?
Yes.
In that, always you can draw the model as a reflective model without what do you call? I will show you this sort of a complex model. I will explain. I will explain. Then you can understand. Now this is the model. I can get these variables. Is somewhat complex part. Latent variables. These new latent variables I can save as Excel one again. As Excel file here I can't because of the student version. You can save them into a comma.csv format again.
Okay.
This. Then I get something like this. I will show you. Again, I save them into something like this. Now I have, you can see here, loyalty, satisfaction, reputation, pricing, quality, all these things you can see here, no?
Hmm.
Do you see that there?
Yes.
Using these, now I can draw a new model.
Okay.
Yeah, I have only one variable now. Now these are becoming indicators. For example, loyalty is becoming one variable now. But early, my original model, I had loyalty 1 and 2. Now that is created as one variable using latent variable scores, Mr. Lasant.
Right. Right.
Using them, you can draw a small model. Are you clear?
Yes. Yes.
I will show you sometimes. Yes, I might have it here. That is how you do that for the confirmatory tetrad analysis for the higher order models. I will show you. It's like this. Now here I have created, but I can do something like this. I will show you. Now reputation, I can form from 3 variables. Using these are the latent variable. One I had, let's say quality. The other one I have now latent variable, single indicator leadership. Another one I have corporate social responsibility. Another one I have governance. Now I reduce the model to a single order level again, using a new set of variables which were created from the initial analysis. We call this a second order test.
Right.
Are you clear?
Now I'm clear. Yes.
Or this one also now I can do tetrad analysis, Mr. Lasant.
Ah, right. 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 Okay.
That's how you identify whether first order and second order also formative or reflective. Again, you can go to the original model and say whether it's a formative or formative reflective or reflective formative or anything. Is it clear?
Yes. 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 Okay.
It's a long process. Anyway, it's a very good question that you ask. anyone who interested, they can try this way. But some people, I don't know whether they understood, but there is something called latent variable scores. Using that, you can do that one. Look at now I simplified the model. This is the original model. This is second order one for reputation. But now look at in this new model, I created reputation into single order one. Dimensions are becoming indicators. Is it clear? Now this dimension became an indicator. Are you clear?
Yeah, that's right. Okay.
Mr. Shenal?
Yes, sir. I'm little bit new to this. I will
Yes,
somehow
yes,
yeah.
this is sort of advanced analysis. We call the two-step approach.
Okay, sir.
I will explain with a different example. That's why I created this one. Some people are talking about this latent variable. That is a new variable created from your original data set. I will explain. Now that's my last part also. I mentioned something like this. Now this is my model. We will assume this is my model. Original model is this. Now this original model we had. Assume that. Now what's the indigenous variable here? Indigenous variable?
Loyalty.
Loyalty. But we will assume like this. Indigenous variable is reputation, but theoretical wrong. But for to explain, let me use that as an example. My indigenous variable is not loyalty in this example. It is reputation. Now arrows are going towards this side, right? Very basic idea, you know that. Further, assume that my this second order construct reputation is the first order one is reflective, but second order one is not reflective formative. Now this is a very common problem people face. They don't know how to solve this issue. It's a special model. An error happening. That's why we have to minimize this calculation error. That's why I'm going to latent variable. One day you will realize it's the first time you understand latent variable concept. Now arrows are coming like this.
You have to connect finance also.
Sorry?
You have to connect finance also. I think that's why.
Yeah, no. Sorry. Thank you. Right. Select height. Now this is a scenario. Don't you see any issue when you run this model? Somewhat you have to think. Now this is a hypothesized model. Any idea? Now loyalty is a larger construct. Satisfaction is a larger construct. Price is a larger construct. But quality, leadership, social responsibility, governance, and finance are in a small circle. Those are not the larger construct. Those are the dimensions forming reputation, which is a larger construct. Do you understand?
Yes.
Now you can see this is a, at the second order level, this is a formative one, no? Reputation. First
Yes.
order reflective, yes. Yes. Now, when you run this model, loyalty, satisfaction, pricing taken as independent, and also this model understand theoretically quality also like loyalty independent variable. Dimensions also like these variable, they understand as independent variable. Then what's happening? I am running the model, see the issue. We go for path focus. Start calculation. Now in this model, you say issue. Here, R square is not calculated. That is one problem. Sometimes if you calculate the R square in this model, that is 1 and above. Why is that? Any idea? R square is 1 and above. 1 or above. Why? It is not only these three independent variables. These variables are also contributing to this one. But this is also formed from these variables indicators. Can you remember? Those are also there. If you see this. That's a problem. It's a double counting error, something like that. That's a concept. Such a concept is happening. I don't know whether you understand the issue.
Understood.
Only in this case you have the problem. Why? Indigenous variable is a second order formative construct. Indigenous means dependent variable. Here reputation in this my hypothesized model, right? Is not the original model. I just created reputation as a dependent, but not the original model. Now I have not only three independent dimensions also becoming independent like and creating a total effect on the reputation.
But
Yes.
sorry, Professor, it won't happen if it's the exogenous variable, right?
Never ever, yes. Only in this case you have the problem, Mr. Lasant. Yes.
Right, right.
Well understood. Yes.
Okay.
In other cases, no issue. Why? Then arrow is not toward this side, other side. When this is indigenous variable is only second order formative only, this problem is there. But when the arrows are when this is exogenous, no issue. Your predicting variable is something different in that case, but here you are going to predict reputation. You are going to predict reputation using independent variables as well as dimensions. Now that's a problem. That's a problem. Therefore, in that case, you run this one with PLS algorithm, not consistent. Remember, PLS algorithm, you run with factor focus, start calculation. Then you get reports. Don't look at the reports. Go to latent variable. And this is something new to you. Latent variable. Latent variable means our construct, which is not visible. There is something under latent variable. First matrix is about latent variable scores. That is, scores term is not there, but that is latent variable scores. This is statistically calculated by the program using factor loadings multiplied by outer weights multiplied by standard deviation. and with some adjustments, right? Statistically, there's a separate calculation that is not required at all to you as a power user. From that, we create latent variable. Latent variable is a particular reflection of the larger construct as a single indicator. For the moment, try to understand that way. Usually that is having standard deviation of 1 and mean of 0. That means that is normalized. It said terms, right? Standardized terms. When you are trying to make something normalized, you reduce mean and divide that by standard deviation. No, that process is happening. Therefore, maximum it can be 3 point something plus or minus, right? Now your dimensions are becoming single indicators. See, social responsibility 2 indicators are becoming 1 indicator. Finance 2 or 3 becoming 1. Even the loyalty also becoming 1. We had 2 or 3 loyalty, right? Then the pricing 2 we had, it's becoming 1 indicator. This is not an indicator, we call latent variable scores, right? Standardize. Now this one you have to save into Excel and save as a comma.csv file. Easily you can do that in the professional version, right? Now all the cases are there, dataset respondents. For each one, there is a separate indicator created as a latent variable score. That one you have to separately save. Then you see something like this. Can you see? That is normally between -3 and +3, right? I have given sample here. Loyalty, likewise, you can see for 95 cases, you can see that, right? We call latent variable scores. This is important for advanced analysis. Remember, one day you might be familiar with the term latent variable scores. In that case, you can remember how to get them in PLS. Right? Now that is there. I save that as a comma.csv file. Usually into PLS, you have to save as a comma.csv and you have to import, right? That's a process. Any file. See here, I have imported that one. See, latent variable correlations are there. Latent variable, those things are here. But in my new model, I create a new model now. Okay. Now this model I reduce. Sorry, this complex model, right? Reputation, satisfaction, loyalty, pricing. I reduce into a first order model using this one. Latent variable scores. Now I draw the new model using new data set. Remember. Now reputation, I don't need here 3 things of reputation. Why? For the reputation also single latent variable is created, Mr. Lasantha. No need to use 3 indicators. Directly you can get the single latent variable score created for reputation. That would do at this level in the final model. When you're having second order formative indigenous, only you have to do this, right? Only in that case. We call this a 2-step approach in PLS. First step was to draw the model, get the latent variable scores, then save them into a separate comma.csv, then draw the simple model. Yes. Any clarification? Reputation, price, single one is there. Then loyalty, single one is there. Satisfaction also, originally also single indicator. Now also you can see, right? Single one. Remember, in such a model, usually we have reflective nature, right? Usually this is a reflective. There is no arrow headed, but usually this is taken as reflective. When you are having latent variable ultimate model like this, there is no direction, but this is taken as a reflective one, not the formative. That means a latent variable scores you have created for the final variable in this case. Now this is a model. Now you have to run simply with the new data set. Simple model. This is the second steps, two-step approach. Now we go for consistent, right? Assuming this is reflective. Now here you have to go path focus. You can go to the model. Sorry, it's the model. Sorry. Yes, this. Now remember, they are having factor loading one, right? When there's a single variable, only one factor load. That's a nature. I calculate consistent algorithm bootstrapping as well. Right? Path focus. You get the reports also. You can get the reports. Now you see here, you can have in a model path and p-values. Now this is the one. When a moderator, mediator also possible to be incorporated here using latent variable, right? For the moderator mediation also latent you can bring when there are such cases. That is applied to every variable. That's a perfect reflection of the indicators with minimized errors, issues using the latent variable scores. That's a mirror. Now this is a simple model. In complex, sometimes you are having third order construct, second order, third order. Ultimately, after having the measurement model tested for the larger model, final inner model you can do like this. When you are having second order formative indigenous variable, only in that case, Mr. Lasandra. Is it clear?
Yes, now does the rule of 4 apply for the dimensions as well?
I didn't get you.
See now, now to check whether it's formative or reflective.
Yes.
The rule of 4 apply to dimensions also now. Let's say you have
Possible. Possible. You can.
It has to meet, is it?
Yes, yes. Now, as I mentioned in the previous example here, reputation, if you wanted, you could have measured using not reputation, latent variable score, other 3 scores, other 4 scores, corporate social responsibility, latent variable, and and you could have done that. But that the purpose is not to test the model, but to understand whether second order ones are formative or reflective. Only in that case you do that.
Sorry. No, so if the second order construct has, say, 3 dimensions.
Okay.
If those 3 dimensions we hypothesize as formative, then can you run this second step? Because there are only 3 dimensions.
Second step means to identify, you mean to identify the formative or reflective, or to measure the final model?
Yes. To understand whether it's formative or reflective.
Then you cannot. that limitation is there.
Okay.
That's a limitation. In that case, you have to talk to the expert, and you have to have some other qualitative methods to ensure whether it's a formative or reflective. I think that's the only way we can do in that case.
Okay.
You need tetrad means groups of 4, no? In that logic, yes. Those are some of the areas, but still they are developing some models and the developments in this PLS. In the future, sometimes we might get better options, I think. For the moment, these are the available techniques and the strategies.
Right, okay. Thank you.
But I think we have done a significant amount of works now, how to identify formative or reflective, but constraints are there. You need 4. That's the case. Other thing is to have some expert interviews and to understand whether second order one is formative or reflective. That can be more practical than using this approach.
Because in my case, the second order for that particular latent variable, the second order dimensions have always been used as reflective.
In the
But
literature.
in the literature.
Then you
That
don't
would be
have to
good.
worry.
Yeah, but see, the problem there is they are borrowing it from some other place.
Sorry, they
Right?
are.
They're borrowing those dimensions from another part of theory.
They or you.
They. But in my situation, what I'm arguing is that if you want to have that, the variable is dynamic managerial capabilities. If you want to have that, if you want to identify that capability in the organization amongst those managers, then they have to fulfill all three. You can't have only two.
That means you mean formative.
Then it's formative. That's what I'm trying to argue. So there is, in theory, in the literature so far, they have very loosely taken it as reflective. I don't agree with that.
That means they have done the research in the past using Amos maybe approach.
Yes.
That's the only way in Amos, reflective.
Right. Okay. Now I understand.
Amos වල තියෙන ප්‍රශ්නේ ඕකනේ ඒගොල්ලන්ගේ reflective විතරයි කරන්න පුළුවන්.
Formative කරන්න බෑනේ.
බෑනේ ඒකනේ දැන් මේකේ තියෙන advanced nature එක තමයි දෙකම පුළුවන් අපිට ටෙස්ට් කරන්නත් පුළුවන් ටෙට්‍රඩ් එකකින්. හැබැයි what you say might be correct I think as your argument.
Oh, because I mean
But you say that
cognition.
managers have to fulfill those three things.
When they talk about cognition, social networks, and something a third one. So
yes.
all those
when
three
those
things
three are existing, the
yes.
larger construct is happening.
So that has to be there for the larger construct.
Second order formative, no? Second order formative.
So that's the way I'm arguing it.
Second order formative.
Yes.
But you are having only three dimensions.
3 dimensions.
Yes. But what about their first order indicators? Formative or reflective?
First order indicators are reflective.
Then how can you say that?
That is, for that the literature supports, because those have been tested independently, separately. For example, they have tested cognition and social networks and its impact on something. So this concept is fairly new now, what I'm doing right now for my study. When you look at my model, you will see.
Okay, we will have a sort of a meeting in the next week.
Okay, right. Thank you.
Anyway, now you understand the process, no?
But I understand the process. Now I understand. Yes. Thank you.
Thank you. Then I think we have discussed a lot of things. Then you can further watch the video again and try to understand. Then third session, fourth topic also we discuss. Then I think with that I can conclude. If you don't have any clarification, we can conclude, I think. Any clarification from the others? Unless you have any clarification, we can wind up. Hope you understood, but sometimes this last part, latent variable scores may be something new to you, but that is very important. Remember, one day you remember, if you sometimes use R software also in addition to analysis. Like sometimes you have to combine PLS or Amos with R for some advanced analysis with some programs, R Studio. In that case, you have to take your latent variable scores into R, right? That is to advance your PLS analysis to another more sophisticated analysis. You have to take from your latent variables, right? With the latent variables, you have to go to R. That's why this latent variable concept is important, remember, right? That is something understood by R also. In R programming, you need latent variable scores. If you want to do some bottleneck table and certain other advanced analysis, we call some different techniques, necessary condition analysis. Likewise, there are some advanced things with R. PLS can be combined with R using latent variable scores. Therefore, remember, to link to R, you need latent variable scores for advanced analysis. I think with that, I think we can conclude. Thank you very much for your support and the patience. Then we will wind up. Thank you very much.
Very good evening to you all. Firstly, I need to say sorry that I am not being able to continue with my video option because of the power cut in my area. It is really a great honor for me to deliver the vote of thanks on behalf of the head grants, Department of Accountancy and Finance, Sabaragamu University of Sri Lanka. I would like to offer my sincere gratitude to Professor S.D. Samarasinghe, Department of Industrial Management, Faculty of Business, University of Moratuwa for sparing his valuable time from the busiest schedule to grace this event. Thank you so much, sir. This session was really very meaningful and interesting. And also, I would like to thank Professor D.G. Dharmaratna, Head, Department of Accountancy and Finance, Faculty of Management Studies, Sabaragamu University of Sri Lanka. Then, I would like to thank Senior Lecturer, Mr. Malit Amarasinghe, Project Coordinator, Head Grants, Professor Jayantha Devasiri, and all the academic staff for their dedication on making this event a great success. Finally, I would like to thank you all, the participant, for being with us. So again, thank you all. Stay safe and have a good night. Thank you.
Thank you very much, Ms. Upeksha.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you, Professor. Thank you very much.